All right. Quiet, please. It's time again. So,
He's trying to teach.
thank you, Micah. Now it's a good. Maybe. All right, guys. So we're gonna continue our chat about exponential functions. So take good notes because tomorrow's the day we're gonna actually work on the practice problems in class and stuff, right? So, anyway, so we're gonna do two things with these today. We're gonna evaluate, and what that means is I'm gonna give you an exponential function. You're going to plug a number in and get an answer. We're going to learn how to do that by hand. But we're also going to learn how to do it with a calculator. And after we learn that, we're going to start turning these equations into pictures, a graph, so you guys can start this process of graphing these things. That's going to be a 2-day lesson. So we're going to do half of it today, the other half another day. So that's pretty much the gist of where we're going with things today. All right. So... Sure. Real quick review before we begin here. Well, no, we'll just kind of jump in and we'll kind of review as we go. Example 1. No, you have plug 4 incorrect. All right, so just to kind of review, what this means, we've got a function here. And what this means is we're going to plug 4 in for x to see what it equals. So we're going to take this expression here, f of x equals 2, 3 to the x. And wherever the x is at, we're going to put a 4 in its place. So it's going to look like that, right? 81. You got it.
Excuse me.
So, nice. You know what you're doing. So here's what we got to do. You guys got to do Pemdas, okay? Now, we're only going to do 2 of those things, though. Pemdas has 5 things, right? We're only going to do 2 of them. Exponents and multiplication. Which one comes first, exponent or multiplication?
Exponent.
Good. So you do this first. The problem is you guys all know how to read, right? But we're used to reading, I hope so, left to right. But that's not how you do math. You don't do the math left to right. You do the exponents first, and then you do the multiplication. So it's going to be 3 to the 4th power. That means 3 times 3, which is?
9.
Times 3 times 3. 81. So 3 to the 4th power is 81. And then you do times 2, and that's 162. There you go. That's it. So for this one, a little note you might want to make is, remember, exponents before multiplication. Exponents before multiplication. All right, let's do another one here. Number 2. How about f of 0? Let's find out what f of 0 is. So that would be, what was my function? Was it 2?
Yeah.
And then 3 to the what power now? 0, because we're plugging in 0 now, right? Okay, so what do we do first? Exponents. And what is 3 to the 0 power? 1. Weird stuff, but there it is. Weird stuff, but there it is. If I were to graph this is like my this is my x value, right? This is my y value. I plugged in something for x, I got a y value. Now, if I wanted to graph this on a graph, you guys, where would I put my dot? Anybody know?
0,
0, 2. Good. So that's right here. What do we call that point? The y-intercept. Good job. So when you plug in 0, you get the y-intercept, right? All right. So let's make a little note about that. We're getting there. Yes, we will. Now, you guys notice that when I plug in 0, what happens to this thing? It just becomes 1. And so basically, you're just going to be left with that number there. You guys remember how I called that the starting amount when we were doing our word problems the other day? So here's a nice connection for you now. The starting amount is the y-intercept. There you go. Starting amount equals y-intercept. So there's that. So we've learned a couple things here. Exponents before multiplication. When you plug in 0, you get a y-intercept, and it's just basically going to end up being your starting amount. Cool? So now we get to play with fractions, because I know you guys like those, and we don't want to leave those out. Fractions are your favorite. Fractions are fun. All right, here we go. So how about, I'm going to give you a new function. Now I'm going to call this one g of x. And I'm going to say g of x is equal to 2/3, and then I'm going to put 5 to the x power here. And then I'm going to say find g of 2. Okay, so what's the first thing I do? Plug it in. So it's going to look like this. You guys good? And what do we do first? Exponents. What's that going to be?
25.
25. Okay, now here's where the new thing comes in.
Over 1.
Yeah, just put it over 1 and go straight across, right? Now I'm going to write this as a second step. I usually wouldn't do this if I was just working out, but it's nice to see it in your notes. This is what we have, and what we're going to do is we're going to think of it like this, like Micah said, and then we're just going to multiply straight across to get 50 over 3. Are you talking to me?
Yeah, you said like Mike is.
Wasn't it him? You were the one that said over 1? Oh, I thought it was him. Sorry. Like Henry said. So, when you have a number being multiplied by a fraction, just think of that as over 1 and just go straight across, okay? And when we graph these today, we're going to be changing these into decimals. This is fine for now, but later we'll turn that into a decimal, so it's a little bit easier to graph. That's a weird looking number there. All right, so let's do one more before I let you guys crack. Whoa, whoa, whoa. Simmer down. Simmer down. All right, one more. How about this number 4?
Yes.
All right, how about h of x? I'm going to give you a new function. Is equal to 1 over 2 times 3 over 4 to the x power. Now I'm going to make both of them fractions because fractions are fun. And we're going to do h of frustrating. Stop. This is peaceful. Get some lemonade and sit on the beach and do problems like this all day. I actually have done math on the beach a few times. Now that you mention it. That's funny. But I don't find math peaceful. I do find it engaging and interesting. It actually kind of makes me tired sometimes. Okay, here we go. So, step 1, plug it in. Step 2, power. So here's where the new thing comes in, okay? How do you raise a fraction to a power? Well, you don't have to write this, but that just means I'm doing 3/4 multiplied by itself 3 times, right? And we already talked about how it's just straight across. So really it's just 3 to the third power and 4 to the third power. In other words, just raise both of those to the third power. Okay? So what's 3 to the third power?
27.
And what's 4 to the third power?
Nah, 60 times
64.
no way.
And if you don't know it off the top of your head, that's fine. Just make sure you know how to calculate it. 4 times 4 times 4, right? Now we go straight across, right? So that's going to be 27 over 128. Okay? And that's evaluating by hand. So no calculators, just
Why did you want to do that? It just popped in my head.
I like
favorite
math.
subject or something?
I like math. Yeah? This is your practice time, student practice. Sure. Okay, so let's say I have f of x is equal to 5 times 2 to the x power, and I want you guys to find the following things. F of 4. I want you guys to find f of 0. Then I want you guys to do this one. And one more. Okay, there you go. Okay, so let's review something really quick together. Negative exponents. Well, first of all, you guys, you know this, yes? Huh? Yeah. All right, so we talked about how to do this. When you have a fraction being raised to a power, basically what you do is this, right? Okay, but what happens if you're raising it to, pay attention guys, this one's confusing. What happens when we raise it to a negative power? Well, the same thing. You're still going to put the negative here and here, okay? But now it's a negative power, right? And you guys might have forgotten this, but with negative powers, it's that unhappy goat rule, remember? It's like it doesn't like this grass, so it wants to go to the other grass. So they're both going to switch. The B is going to come up here, and the A is going to go down here so that their exponents can be happy. So there you go. If you want to, you can. That's the rule we're going to be using, though. So like, for instance, if I gave you guys this, what's the, what kind of, you can write it or just watch. I'm not really doing an official example right now. I'm just thinking what to use. This would be good. I want to make sure people got it. What does this equal, you guys?
9 over
16, right? Because it's 3 squared, which is 9, 4 squared, which is 16. But what would this be if I gave you that? It's going to be the same thing because you're still squaring it, but since it's negative, it gets flipped. So you square it and flip it. All right, so let's do another example here to kind of solidify this idea. How about no, not yet. Just keep watching with me. 7 over 2 to the negative 2 power. What's that going to be? 4 over 49. If you square 2, you get 4. If you square 7, you get 49. And we flip it because it's a negative exponent.
Oh, okay. I was like, whoa.
So you square and flip. How about this? 8 over 3 to the negative 1 power. What would that be?
So it'd be 3 over 8.
Just 3/8, right? Because the power of 1 doesn't change anything, but the negative flips it over. So that's what negative exponents do. You still do the power like normal, but you also flip it. Okay? Now, what if you have this, though? Like, let's say you have 5 to the negative 2. Yeah, so if you have a whole number, okay, then what you do is you think of that as a fraction, and then you square it. What's 5 squared? And what's 1 squared?
2, 1.
1, but we're going to flip it. So what's the answer? Okay? So with a whole number, just think of it as a fraction, square the top and bottom, and then flip it. Okay?
What about if it's
Then you don't flip it. You still do the power, you just don't flip it. Like that's what we did last time. Let's do one more. What's that going to be? 3 to the negative 3.
put it 1 over 3. It's going to be 1 over 9.
Did you say that?
No, Sam.
Oh,
I was thinking.
okay.
I was going to say 9.
I thought it was you. Sorry. All right. So let's do an example 2. Same idea, guys, but just we're gonna do some examples with negative exponents. So now's where you want to start writing, Hannah. So let's say I have 5 times 1/2 to the x. And let's say that's f of x, right? And we want to find f of negative 3.
Oh.
Oh, well, I'm gonna go through a little bit slower, but I know you got it. Smarty pants. All right, here we go. So first thing we're gonna do, guys, is we're going to plug it in.
8 over 1.
So if we plug it in, it looks like this. The next thing we're gonna do is we're gonna do this, the exponent, right? So what is 1/2 to the negative 3 power? Go ahead, Henry.
With lift and everything, 8 over 1.
It's 8, right?
Yeah.
Good.
Oh.
So 8, you could say 8 over 1, it's fine, but it's 8, right? So first of all, 1 to the 3rd power is 1. 2 to the...
Oh, what I... Hey, I see them.
Just pause the recording.
Yeah, 1, right? And if you want to think of that as over 1 and multiply straight across, you're fine. But either way, you just get 40, right? All right, let's do another one here real quick. F of well, I want to do a different function actually. Sasha and Annie, let's not talk right now, please.
Wait, why is there a big
Just nothing big, no big deal. Okay. All right, so what's the first thing I'm going to do, Natalie? Good. Okay, the next thing we're going to do, Rowan, is what? Yeah, so you're talking about this, right? So I'm going to stop here. I want you guys to take a minute, see if you can figure that out, and I'll call you in a second to tell me what you get there. Did you get that yet, Daniel?
Nope.
Daniel?
Yeah. Isn't it 6 over 4?
The final answer?
Oh, you want the final answer?
No, no, just the 2 over 3 and the negative. You said 6 over 4? You're close. It's not 6, though.
Oh, 9 over
9 over 4. Good. So 3 squared is 9, 2 squared is 4, and you're going to flip it over so you get that. Javier, what's next? Yep. So you get 27 over 16.
This is easy.
Good. All right, I'll give you guys one more of these to try, and then we're going to move on to our next part, okay? This one you'll do completely on your own.
Let's do the practice or what?
Yeah, we'll call it a student practice, too.
Okay. That's the same thing, right?
Yeah. Go for it. Show me what you got. All right. If you don't have a calculator yet, now you might want to grab one. We're going to do some calculator stuff. We're going to move into graphing now. We're going to do most of our evaluating with calculators at this point on. What I'm going to do is I'm going to ask for David, give me a number between 1 and 5. Well, 2 and 5. Between 2 and 5. 4, okay. So this exploration that we're doing, you guys, is going to be to see what happens when that number is bigger than 1. Now, I told Dave to stay between 5 and 1 because if it's too big, you end up with numbers that are stupidly large, and it's just impossible to work with. 4 is going to be pretty big, too. But anyway, so this exploration is going to see what can we conclude about the graph of an exponential function whenever that growth factor is bigger than 1. So let's give that a subtitle now. Growth factor is greater than 1. So David picked 4, and that's the one we're going to work with there. All right, so what I want to do is I want to make a table of values here. You guys can do this with me real quick. Let's do -3, -2, -1, 0, 1, 2, and 3. Now we could do this by hand. Based on the things I've taught you already, you guys should be able to plug in those numbers and figure out the answers by hand, but I don't want you to. I want you guys to know how to do it with a calculator. So let's do it with a calculator. So first of all, to find this one, guys, we're going to plug in -3 for the x, okay? Now, I'm going to write this down. You don't need to write it down necessarily on your paper, but I am going to tell you what I want you guys to type. So I'm going to plug in -3 to my exponential function there. Now here's what you'd type. On your calculator, you're going to push 2, parentheses, 4, parentheses. You're going to find your little caret button, and you're going to push -3. Now be careful, though. When you type in -3, make sure it's -3 and not -3. If you say -3, your calculator is going to say error. The negative button is the one down here on the bottom. That's the one we want. We don't want the minus button. We want the negative button on the bottom corner. So go ahead and type that in and see what you guys get, and then just push equals. You should get an answer, and we're just going to round it to the 10th place. That's the first number after the decimal. So let me ask, he's not here today. Let me ask Alicia, what did you get by doing that? 0.03? Okay, now we're only going to go to the 10th place. So what is that number then basically? It's just basically 0. It's so small, it's basically 0. Okay, now it's not really 0, but it's basically 0. All right, go ahead and do the same thing for the next few points here, -2, -1, 0, 1, 2, and 3. And see what you guys get. I'll give you a few minutes, so I'm calling you to share out your answers, okay? Plug them in, get the answers. I want to graph this data now. So let's go ahead and make an XY chart. I'll do a couple of the points for you, and I'll let you guys do the rest. Now, guys, look how big the Y values go to, right?
Yeah.
So on my Y-axis, you don't want to count by ones. You don't want to make 128 marks, do you? That's going to be irritating. Let's count by like, want to go by tens? 10 will be good. Let's do that. 10, 20, 30, and so on. Even, I'm still going to go off the chart here.
Or you just stop at 2.
Yeah, I guess so.
Because realistically, you only get 2 points.
I guess so. We could try that. All right, so let's graph it. Now was this really 0, you guys? But it's so small it basically is, right? Okay, so we're going to go -3, 0. So 1, 2, 3. So we're just going to put a dot like right about there.
What? Oh.
-3, 0. How about -2.1?
You go up just a little bit after that.
So -2 is going to be right here, right? And then 0.1, is that going to look any different than 0?
No.
Not to our eyes, it's not. I mean, if this is 10, 1 would be like here. 0.1 is going to be barely even visible, right? All right, so let's do the next one. -1 and 0.5. I guess you're feeling generous. You can go a little higher. But once again, if this is 10, then 1's going to be like right here. So 0.5 would be like right in the middle there. So it's very slow growing. All right, the next one. What's the next one? 2. So like maybe like here. Oh my goodness.
Whoa.
Interesting. Interesting. Have I told you I don't? Have I told you I don't like my new board?
Yeah.
Okay, I just want to make sure I emphasize that. No, I hate this thing. It's been nothing but a pain in the butt since I've had it. All right, you guys go ahead and plot the rest of those points and connect the dots, okay?
You know if I do that, just to make it straight. So I'd like to point out, you put the dot under 3.
Yeah, close enough. Thank you, though. You're right. Okay. So guys, I want you to help me complete this following sentence. Ready? And you might want to write it down too. Here we go. Write this with me. As x gets more negative, y gets closer to blank.
To what? So it's just gonna be
As
blank.
x gets more negative, y gets closer to.
Blank.
Oh, the 0. Yeah.
Good. So
It's closer to 0. The x-axis.
that works too. All right, so guys, here we go. As x gets more negative, so like I'm going this way. As x gets more and more negative, -1, -2, -3, y gets closer and closer to what number?
0.
0 is the answer. Now, when you look at that on a graph, you guys, as x gets more negative, that means as I move to the left, y is getting flatter and flatter. It's getting closer and closer to that x-axis. And that's our asymptote that we talked about. It never gets to 0, but it will get closer and closer. All right? So here's how we write this in math. Oops. Not like that. Here we go. Write this with me. As x gets more and more negative, that's what that means. X is approaching negative infinity. It's going to the left. It's going more negative. What is y approaching? 0. There you go. This is what we call the end behavior. Okay, guys, there's a lot of distractions out here. Got a lot of side conversations. Hang in there with me, guys. We're not done yet. I know it's not your favorite thing to be doing right now, but we need to pay attention so we don't get lost later. All right, so as x gets more and more negative, y gets closer to 0. Let's look at another thing here. How about this? As x gets bigger, y gets
farther away from 0.
true.
Or more bigger.
Oops. There you go. Y gets bigger.
Yeah, y gets bigger.
There you go. So take a look at your chart here. As x gets bigger and bigger, what's happening to the y values?
Bigger and bigger.
They're not. Are they reaching a number?
Well,
I mean, are they like, is it getting closer and closer to a number, or are they just getting bigger and bigger? They're just getting bigger and bigger. It's not like this side where it's getting closer and closer to a specific number. They're just going crazy. They're getting bigger and bigger. Okay? So how do you think I'm going to write this? As x goes to
Yeah. Oh, I mean bigger.
How am I going to write bigger here?
Don't let the arrow go up.
Positive infinity. As x goes to positive infinity, what's happening to the y value? Y goes to what?
Up.
Does
What
it ever?
goes up?
Positive infinity.
It goes to positive infinity. Y gets bigger and bigger. And that's what we call the end behavior. Now, it's looking like we're not going to get to do the other half of our exploration right now, but we'll get there.
This is a stupid table. It's not my freaking.
So I want you guys to follow me with some conclusions here.
Yeah.
All right. Can you guys be quiet for a minute and not zip up and stuff? I'm still teaching right now. Give me a second. I'm almost done, okay?
Is there any more?
Let me finish, please.
Still got 4 minutes.
All right. So, what our exploration was, you guys, was we did this. The number that David picked for us is when the growth factor is greater than 1. Here's what I want you guys to take away from this. The graph looks like this. Now, if I were to pick a number that's less than 1, the graph will look a little bit different, just so you guys know. Okay? We might look at that tomorrow a little bit, or maybe the next day. But now, now this is another thing I want you guys to take away from this. When that growth factor is bigger than 1, as x gets smaller and smaller, y gets closer to 0. And as x gets bigger and bigger, y gets bigger and bigger. And you can see that on the graph and also in the table. Okay? So those are the two takeaways. Both of those things, though, the graph and those conclusions are going to change if I give you a number that's less than that. So we'll have to pick up on that one tomorrow. But anyway, go ahead and now you guys can pack up. Thank you for waiting.